Okay, we can't allow the denominator to be 0, so x cannot be equal to 0. Here the denominator is not a variable, so x can be anything. So there are no restrictions on x. So we'll cross this out and put none. We can't make this 0, so we say x cannot be the opposite of this, positive 4 over 3. This cannot be equal to 0, so we have to factor that. And we have x plus 4 and x plus 3. So x cannot be equal to negative 4 and negative 3. We have to factor this. So the first thing I'm going to do is pull out the common factor of x. And then we're left with 2x squared minus 5x minus 3. And then we're going to factor what's left. We put a negative 3 here and a positive 1 here. That gives me 2x squared for first. Outer is negative 6x. Inner is positive 1x. That adds up to that. And this gives us that. So this is 0, negative 1/2, and positive 3. Here we're going to factor this. This is the difference of two squares. So we end up with conjugate pairs on the bottom. 4x plus 5 and 4x minus 5. So x cannot be equal to plus and minus 5 over 4. Okay, we're only finding the least common denominator. So this and this have nothing in common. So the LCD is just the product of those. So the LCD is x times x plus 1. If something can be factored, factor it first. This cannot be factored, but this factors as x plus 3 times x plus 4. So the LCD is x plus 3 times x plus 4. And it's not x plus 3 squared because 1 is the most it happens in any one of them, so it's only going to happen once here. So again, I'm going to factor this and this. This factors as x plus 5 and x plus 2. This factors as 2x, let's see, plus 5 and plus 1, because that gives us a 10 on the outside and a 1 on the inside, making that 11, and the last is 5. So we have, let's see, 1, 2, 3 different factors all happening at most once. So those will happen once in the denominator. So x plus 5, x plus 2, and 2x plus 1. Okay, we have to factor these. To factor this, I'm first going to take out the x. So I have x times x squared plus x minus 12. And that's going to factor as, let's see, positive 4 and negative 3. Okay, this is x minus 3 squared. So when we look at the different factors, we have x, x plus 4, and x minus 3. This happens at most once in either one of them, so it's going to happen once. This happens at once in either one of them, so that's going to happen once. And this happens at most twice in either one of them, so it's going to happen twice. So that's the LCD. Okay, the first step is finding the LCD. Well, the only LCD, the only denominator is x, so that's got to be the common denominator. And that tells us that x cannot be equal to 0. So the new equation is taking this denominator and multiplying it by each of these. So in other words, I multiply it by this and I get x squared. I multiply x by this and the x's cancel and I have plus 28. And I multiply this by this and we get 11x. So this is an equivalent equation, but there's no fractions now. So now this is a quadratic, so I'll solve it by setting it equal to 0, move that over. And I'll factor. So I'll get x is equal to positive 7 and positive 4. Before I write it down as my solution, I got to remember to check my restricted value, which is 0. So these are okay. So 7 and 4. Okay, before I can figure out the LCD, make sure these are all factored. This is factored, but this can factor. So now hopefully you can see that the LCD is that. And the restriction is both positive and negative too. So when you're multiplying this, basically the easiest way to do this is to multiply the numerator by what's missing from the denominator. So in other words, I'm going to take the numerator x and I'm going to multiply by what's missing from the denominator, x minus 2. And then I'm going to have minus, and I'll take the numerator, the 1, and I'll multiply by what's missing from the denominator, which is x plus 2. And then I'll take the numerator 8 and I'll multiply by what's missing from the denominator. Nothing's missing from the denominator, so I don't multiply that by anything. So that's my equation without fractions. Now I'm going to distribute this x and get x squared minus 2x. I'll distribute the negative 1 and I'll get negative x minus 2 equals 8. So x squared minus 3x, I'll bring this over, and we'll have minus 10 is equal to 0. So we have x minus 5, x plus 2 is equal to 0. So x is equal to positive 5 and negative 2. But when we look back at the restricted domain values, x cannot be negative 2. So I have to cross this out. And the only solution left is x is equal to 5. Okay, my first step is to factor any possible denominators. Can't factor that, but this factors as x times x plus 1. So that is my LCD. So x cannot be equal to 0 from this and negative 1 from this. So those are my restricted values. Now, I'm going to take the numerator and multiply by what's missing from the denominator. So I'm going to take my negative 3x and I'm going to multiply that by what's missing from the denominator, this x. And then I'm going to have plus my numerator, 4x plus 1, and I'm going to multiply that by what's missing from my denominator, which is x plus 1. And then I'm going to have equals negative 3. Okay? And I'm going to multiply that by what's missing from the denominator. And nothing's missing from the denominator, so I don't multiply that by anything. So this turns into negative 3x squared. And this is a binomial times a binomial, so I need to FOIL. So the first is plus 4x squared. The outer is plus 4x. The inner is plus 1x. The last is plus 1. And then I'm going to bring this over and I'll have plus 3, and now it's equal to 0. Okay. So I'm going to combine like terms. We have negative 3x squared plus 4x squared is 1x squared. 4x plus 1x is 5x. And 1 plus 3 is plus 4 equals 0. So this factors as x plus 4 and x plus 1. So we have x is equal to negative 4 and negative 1. But I can't write these down because our restricted domain values, one of them is negative 1. So this is not allowed, and I have to throw that out. So I have my final answer is x is equal to negative 4. Okay, first step, factor any denominators that you can. Can't factor, we factor that. And that's going to be 2x and x. Put a negative 5 here and a plus 1 here. So that is the LCD, because there's our x minus 5 happens once, there's our 2x plus 1 happens once. Nothing happens more than once. So 2x plus 1 and x minus 5. That means that x cannot be equal to negative 1/2 or positive 5. Negative 1/2 from this and positive 5 from that. So now we're going to take the numerator, the 2, and we're going to multiply by what's missing from the denominator, which is 2x plus 1. Then we're going to take that plus 3 from the numerator, and we'll multiply by what's missing from the denominator, the x minus 5. and that's going to be equal to the numerator times what's missing from the denominator, and nothing's missing, so we don't multiply that by anything. So I'll take the 2 and distribute that and get 4x plus 2, take the 3 and distribute that, plus 3x minus 15, and then I'll move this over, and we have minus 22 equals 0. Combining like terms, I have 4x squared. Let's see, we have, oh, wait a minute. I take it back. I'm so sorry if that was bothering you. This is not a squared. There's no squared there. So this is just 4x. So now when we combine, actually I shouldn't have brought that over. When I combine like terms, I'm going to have to move those numbers over there, but let's just combine like terms. We have 7x, and then my numbers are 2 minus 15, that's negative 13, minus that is negative 35. But this is not a quadratic, so it shouldn't be set equal to 0. Now I got to move that back. I should never have moved this over here because I didn't have a squared term. Anyway, this is 7x is equal to positive 35, so x is equal to 5. But when we go back, x cannot be equal to 5, so we have to throw this solution out, which means there are no valid solutions left, so this is no solution. Okay, I'm going to factor this, this, and this. So this becomes x plus 3, x minus 1. This is going to become a 3 times 1 minus x. And this will become a 3 times x plus 3. But what I don't want to have a 1 x minus 1 and a 1 minus x. So instead, I'm going to make this a negative. Well, let's pop the negative up to the top here. So, or actually right there. So we'll change this to a plus, and I'll now make this a 3 times x minus 1. That's a confusing deal, but if you make this the opposite, we have to make the entire fraction the opposite, because a negative is a positive. So that now becomes a plus, and now that's our denominator, that's our denominator, and that's our denominator. So our LCD is 3 times x plus 3 times x minus 1. And this does not contribute to the restriction. We have a negative 3 from this and a positive 1 from this. Okay, so our new equation is we're going to take the numerator, the negative, and we're going to multiply by what's missing from the denominator, and just this 3 is missing. And then now it's not going to be minus 5, it's going to be plus 5, and we're going to multiply this by what's missing from the denominator. Oops, this right here, x plus 3. And then we're going to say equals the numerator, the 4, times what's missing from the denominator, the x minus 1. So here we have negative 6, I'll distribute this, plus 5x plus 15 is equal to 4x minus 4. So we have 5x, negative 6 and 15 is plus 9 equals 4x minus 4. I'll move this way and this way. 5x minus 4x is 1x, and negative 4 minus 9 is negative 13. Oops, that's an equals there, but it's a negative 13. So I get x is equal to negative 13, and then when I look back at my restricted values, negative 3 and positive 1 are not okay, but negative 13 is okay. So that's the solution. Okay, here I'm going to factor what's possible. So I'll factor this, and I have 3 times x plus 3. And 15 is okay like that. And this was 5 times x plus 3. So my LCD, 15 is the smallest number that all of those can go into. And x plus 3 happens only once. So the restricted value is just negative 3. Remember, this is not a variable, so it doesn't add to the restricted values. So now, I'm going to take my numerator, the 8, and I'm going to multiply by what's missing from the denominator. In order to get this to this, we'd have to multiply by a 5. And then we'll take that negative 8, and I'm going to multiply this by what's missing from the denominator, so x plus 3. And then I'll have equals, I'll take that numerator of 2, and I'm going to multiply this by what's missing from the denominator, and it's a positive 3. Okay, so we have 40, I'll distribute this, minus 8x minus 24 equals 6. So we have negative 8x plus 16 is equal to 6. I'll bring this over. So negative 8x is equal to 6 minus 16, or negative 10. So x is equal to negative 10 over negative 8, which is a positive 5 over 4. And the only restricted value was negative 3, so this is okay. So the solution is positive 5 over 4. Okay, first thing we want to do is factor any denominators possible. This is the only one that's factorable, and that's x minus 2 times x plus 1. So that is our LCD. Oops, what did I just do? So the restriction is positive 2 and negative 1. So now I'm going to take the numerator and I'm going to multiply that by what's missing from the denominator. So x minus 2. And then I'm going to take this numerator, the minus 3, and I'm going to multiply this by what's missing from the denominator, and nothing's missing. So that doesn't get multiplied by anything. Then I'll say equals 3. And I'll take this numerator and multiply by what's missing from the denominator. So just this x plus 1. So now I'll distribute this, and we'll get 2x minus 4 minus 3 equals, I'll distribute this, and get 3x plus 3. So we have 2x minus 7 equals 3x plus 3. I'll move my 2x this way and my 3 this way, and I'll get x is equal to negative 7 minus 3 is negative 10. And this is not a restricted value. So that's our answer. Okay, first step, factor any denominators possible. That's this right here. We'll factor that. And this is x minus 3, x minus 2. So that is the LCD. So the restricted values are positive 3 and positive 2. So now remember, you take the numerator, the 3, and you multiply by what's missing from the denominator, the x minus 2. Then we have minus 3, the numerator, and I multiply this by what's missing from the denominator, and nothing's missing. So then we have equals the numerator 2, and I'm going to multiply this by what's missing from the denominator, x minus 3. So here I'll distribute the 3 and I'll get 3x minus 6. And I'll distribute the 2 and get 2x minus 6. Well, negative 6 is going to cancel on each side. And I'll move this 2 over and the 3 over. And I'll get 1x is equal to positive 3. But when we look back at our restricted domain values, x cannot be equal to 3, and this has to be thrown out. So this is no solution. Okay, the sum of the squares of two consecutive positive odd integers. Well, if x is the smaller integer, or the first integer, the next one would be x plus 2. Odd integers are 2 apart. So this is the second integer. I know there's some confusion because this is not an odd number, but odd numbers are like numbers 13 and 15. To get from 13 to 15, you have to add 2. So those are consecutive odd integers. Now, the sum of the squares, if I square this and square this, I have x squared plus x plus 2 squared. That's the sum of the squares, is 4 more than 14 times the larger. Well, 14 times the larger is this, and 4 more than that is this. So this is a half a point, and this is 1/2 a point. Now to solve this, I'm going to use the shortcut. If you don't know the shortcut, you have to write this out twice and FOIL it and combine like terms. But I know the shortcut, so it's the first item squared twice the product of these two. The product of these two is 2x, so twice that is 4x. And then the last item squared is positive 4. If you have trouble with that, just write this out twice and FOIL it, and you'll get to that. I'll distribute this, and we get 14x plus 28 plus 4. Combining like terms, 2x squared plus, I'll just bring this over, and well, let's just combine like terms. Now, I'm going to bring this over and bring this over. So we have 2x squared, 4 minus 14 is negative 10x, and 4 minus 28, or minus 32 is negative 28. First step is always to factor out a GCF. So there's a 2 common to all of them. So let's bring this up here. I'll factor that, and I'll have, let's see, factors of 14 that add up to negative 5 are negative 7, positive 2. So this does not contribute to the solution because it's not a variable. So this gives us positive 7 and negative 2. But the problem said that we're looking for positive odd integers. This is not positive and it's not odd. So this gets thrown out. This is the only positive odd integer. So that's the first integer. The second one is 2 more than that. So solving this would have been another half a point. So the answer is the integers are 7 and 9. And that's your last half point. Okay, last problem. Wade is 3 years older than John. The product of their ages is 12 more than 4 times the sum of their ages. Find their ages. So I'm going to start with, why don't we say J is equal to John's age. Then J plus 3 must be equal to Wade's age. So that's going to be a half a point. You could use X or whatever you wanted. Okay. Now, it says the product of their ages. So I'm just multiplying those things. Is 12 more than 4 times the sum of their ages. Well, 4 times the sum is 4 times J plus 3. That's 4 times the sum, and it's 12 more than that. So here I'm going to distribute, and I'll have J squared plus 3J. This is like 2J here. And so when I distribute this, 4 times 2 is 8J. I guess you could have put 4J plus 4J, and it would combine to 8J. But plus 12 plus 12. 4 times 3 is 12, and then you have plus 12. So we have J squared. I'll bring this over. 3 minus 8 is negative 5J. And this is 24, and when I bring that over, I get negative 24 is equal to 0. So I have J. Looks like a negative 8 and a plus 3. And that will multiply to my negative 24, but add up to my negative 5. So this tells me J is positive 8 and negative 3. Well, negative 3 doesn't make sense. John's not negative 3 years old. So this is impossible, and we'll throw it out. So now we know that John is 8. And Wade is 3 more than that. So John is 8 years old. Wade is 11 years old. And that's it.